Okay, Assalamualaikum warahmatullahi wabarakatuh and morning. So today's topic is GIS in construction. Okay, so what is GIS? So GIS, or the acronym is the acronym for Geographic Information System, is a tool to capture, store, manipulate, analyze, manage, and display geographic data. So in GIS, the key variable is the location or the coordinates. So we can use GIS essentially for every task lah. As now we see that we have been in the recent years, we have seen that we have been using GPS more and more with our smartphones and whatnot. So humans essentially have been creating maps for hundreds of years. So until recently, with the boom of digital maps, digital navigation, we don't really create maps. We just update them. So with the use of satellite navigation in cars, in our smartphones, we essentially know that GPS is important for us to know. So with GIS, we can capture individual location using the X, Y, and Z coordinates representing longitude, latitude, and elevation, and relate these to other location and to specific dates or time that the data was captured. So the date and time for data was captured is essentially important because we want to see the difference when we capture the data on the earlier month or the end of the month. So we can compare both data that we captured. By combining multiple location points, we can then build representation of the real world that we can use for analysis and visualization. So this lay the groundwork for mapping and analysis, which is employed in science and industry alike. So the users can utilize GIS to better comprehend the trends, relationship, and context of their location, improve communication, efficiency, management, and decision making are just one of the few advantages. So GIS is essentially been widely used bukan di dalam construction sahaja, is instead kita boleh gunakan GIS juga untuk dapatkan, we can see the demographic of a location. Dalam satu kawasan tu berapa ramai orang duduk, berapa banyak orang Melayu, Chinese dan Indian yang duduk situ. So kita boleh dapatkan all this data. So dia berguna bukannya untuk dapatkan koordinat saja, kita boleh juga analyze untuk kita nak tengok dia punya crime rate berapa, crime rate satu kawasan tu berapa, dia punya political stand tempat tu apa. So macam-macam lah, kita bukan guna untuk construction saja. Instead GIS memang boleh digunakan secara meluas lah. So this is the example when we are using GIS application. As you can see, this is the 3D map, the 3D satellite map that we already familiar with. Tapi kita overlay kan, but we overlay it with the information. Macam kat sini kita boleh nampak, okay, the red one is taxiway, the blue is runway. This is the construction in progress. So this is the buildings around the area. So all of this we can capture using GIS data. So a GIS system is made up of different type of components. They can assist in providing a specific function. So the components include layers. So the components include layers, objects, attribute values, and links. The components of a GIS system, GIS are typically include, first we need the database. So the database is kita selalu guna CloudGIS, offsite server or onsite server. Software, QGIS, Whitebox GAT, Saiga GIS, Grass, GBGIS, and etc. Ada banyak software for GIS. We have open source punya software pun ada, dan yang based on company pun ada. Okay, hardware kita kena ada digitizer, GPS unit, mobile devices, drones and plotter. So kalau you boleh tengok kat sini dia punya GPS unit lah. Ini GPS unit yang selalu ada dekat, kalau you pernah nampak kereta Google yang ambil gambar untuk street view tu, dia adalah satu GPS unit. Ataupun sekarang memang TNB rasanya, TNB punya kereta memang banyak nampak di jalan, sebab because the TNB want to utilize the GIS punya data for their management purposes. So ini mobile devices and this is the plotter. Plotter ni ini digitizer. Digitizer kita lukis lah tu. Okay, the people that is usually involved in GIS is the land surveyor, but all the data from GIS can be used by construction managers and BIM coordinators. Okay, this is the data type from GIS. Kita ada vector data dan kita ada raster data. So essentially GIS data can be separated into two categories lah. Macam tadi saya cakap, is spatially reference data, which is represented by vector and raster form, and attribute tables, which are represented in tabular form. Ini. So within the first data group, you find two different types. Macam kita boleh tengok, kita ada vector data and raster data. And most GIS software application mainly focus on the usage and manipulation of vector geodatabases. So you guys, you all semua pernah belajar pasal coordinate kan? Coordinate masa building model in CAD. Kita guna Revit, apa semua kita kena includekan coordinates. Tapi semua letak kosong je kan? So kalau nak gunakan betul-betul, kita kena dapatkan the exact location or the exact coordinates yang kita nak build our building. Nanti dia boleh terus geolog dia punya location lah on the model. So in the case of vector types, they can be compared to the ones we use when we design in our CAD software, with the different that GIS vector data are referenced in the global referencing system, meaning the earth coordinate, whereas in a CAD software are referenced in a local reference system with the X, Y, and Z coordinates. So vector data is one of the most common kind of data used in GIS. It comes in the form of points and lines that are geometrically and mathematically associated. So points are stored using coordinates. And raster images comes in the form of individual pixels, and each spatial location or resolution element has a pixel associated where the pixel value indicates the attributes. Macam ni lah kalau vector data, dia just bagi kita dalam bentuk line, dots ataupun points. Dan juga polygon. But kalau raster, dia lebih pada colors. Each pixel on the raster images tu, dia ada its own attributes lah. Kalau hijau adalah pokok ataupun hutan, biru adalah air, dan kelabu adalah jalan ataupun bangunan. So this is the method on getting the data. So there's the traditional approach and the modern approach, depending if the data existed in other formats or they must come from a new survey. So some of these options, macam kita nampak heads up digitizing, requires physical tracing of maps on digitizing table with a path that transform table coordinates to world coordinates using an algorithm or scanning the documents and doing the same with the mouse. So in other cases like the coordinate geometry, they enter survey coordinates into the database, and by using the GPS and we can get the data, or we can access the data using GPS. So geocoding is using addresses to extract coordinates. Macam kita you guna Google Map kan, you just masukkan alamat, then dia akan bagi you location of this place. So basically dia akan cross check from the database di nama tempat tu, then dia akan bagi you coordinates. Okay, next ni lah geocoding, dan juga lastly is image processing. Okay, this is the one of the contoh yang you boleh guna untuk tengok GIS tu lah. What could GIS be used for? Okay, contoh kalau ni dekat Berlin, so kita boleh nampak lah, dia overlay kan the existing map yang ada dekat Google Map ke, dekat Google Earth ke, then dia letakkan information macam ni bangunan apa, bentuk dia macam mana, model dia macam mana. So yang ni tak nampak lah, dia tak ada information. Tapi essentially kalau kita dah ada banyak data, macam yang ni, dia memang ni open source, orang yang buat di models and whatnot. Satu lagi kita boleh guna adalah Google Earth. So kalau Google Earth, dia lagi okey lah, sebab data tu memang semua dibuat oleh Google. Okay, yang ni kita boleh nampak lah. So essentially ini bukannya BIM model lah, because you can see that this model don't have any information on it. And with BIM model, we have to have information. Okay, dekat bangunan ni, bangunan apa, structure apa. Yang ni just dia siapkan satu model peta, dan dia gabungkan dia punya texture di atas tu. Okay, so yang ni adalah Google Earth lah. Kalau Google Earth punya sama juga, dia just a compilation of polygons and model, tapi dia tak ada information. But it's nice to see lah, dia lagi cantik, dan juga data tu bukannya dapat macam tadi kita kena upload, the users have to upload one by one. Tapi yang ni memang Google dah buatkan, sebab dia dapat data daripada photogrammetry dan juga from the point cloud data. So this is the application of Cloud GIS, or GIS in construction. So Cloud GIS for construction surveying is the process of mapping out reference point for the structures about to be built. So macam kalau before construction need to be done, kita dah mapkan lah reference point dia, kita identify what is the road, mana access road dia, apa surrounding building dia. So this is a critical link between design, engineering and contractors. So it's vital that surveying is conducted successfully, and surveying relies on GIS data collection hardware such as the GPS devices and point cloud ataupun TLS punya equipment. So therefore surveyors can create a real world coordinates grid that will guide a build from start until the finish. Next is drone integration with GIS. So drones are remarkably effective tools in construction, sebab Macam saya kata, drones dia bagus dalam construction sebab dia murah dan sebab dia boleh cover a lot of things. Dia boleh buat, kita boleh gunakan drones untuk project monitoring, kita boleh gunakan dia untuk progress report dan sebagainya lah. So drones provide a simple and inexpensive way to visually record progress on a regular basis, giving an instant overview of site status and enabling teams to track progress over time. Third, we can get accurate as-built documentation. So using GIS, we can help automate as-built creation by simplifying the data collection process and providing a single place to store all the project data. So essentially dia macam BIM lah, bina information modeling, tapi dia untuk kita simpan all the geographic information. Okay, fourth is you can use it for structural works in construction. So GIS allows engineers to include a variety of material data and area historical data into the design. As a result, one of the most extensively utilized GIS application is in structural analysis. So by merging 3D GIS maps with normal design techniques, design can gain from previous mistake. So GIS mapping has a lot of advantages over tabular data, which means that engineers can use interactive overlays or 3D models to visualize, to help the clients ataupun the consultants to visualize and to see problems before the first time of concrete spot. So the fifth is work related to transportation. Because transportation is important in construction, kita nak tahu, okay, bila pukul berapa selalu paling banyak kereta jalan. Ataupun kita nak plan kita punya delivery, material delivery and whatnot. So transportation is another prominent sector where GIS can be useful due to its capacity to aid with route planning and logistics. So there have also been advancement in GPS technology that incorporates GIS technologies, and using GIS technology, traffic flow trends can be displayed alongside population change on the same map. So we can choose what layers that we want to see. So all these layers can be shown to the user. Macam kita, kalau contoh kita nak gerak, kita nak mobilisekan plant kita atau machinery kita tengoklah pukul berapa selalu traffic lengang kat tempat tu, tak ada banyak kereta, so kita boleh mobilize atau kita boleh tutup satu jalan. Sebab kita tahu kan, bila kalau construction, kalau orang buat jalan lah senang cerita, dia pergi buat tengah hari masa traffic tengah banyak. So it's not a good practice lah. Selalunya kalau kita nak buat kerja-kerja jalan, memang kita kena buat kerja malam ataupun kita nak kena buat pagi after peak hour. So lastly is sewage works, stormwater and wastewater line. So data from hydraulic and hydrologic model can be combined with GIS to provide a comprehensive analysis of water utility system. So GIS combines data from customer information system, water flow at various nodes, and historical data to anticipate water demand. So plan drainage improvement by combining terrain analysis and flooding data. With all of this can be seen using the 3D mapping that we can get from GIS, which has graphical and numerical data layers that can be accessed with a single click. So this is why GIS is important in construction. So construction progress of the project should be monitored at every time. And because we need to monitor it every time, the use of GIS is essentially important because we use project monitoring as a safety step in construction project, which can alert and advise the organization about the occurrence of construction failures and delays. So by using GIS, kita boleh plan better lah. So data from scheduling software such as project, Primavera is often combined with GIS data to help with visualizing the construction process. Sebab kita boleh masukkan di data from project and Primavera dan kita boleh preparekan lah dia punya construction schedule. Kita bukannya just main masukkan je, okay, buat column ni berapa hari. Kita boleh add, okay, we can add additional data from the environment that can potentially affect the progress of the construction. Next is, as BIM uses widens, construction people will increasingly be exchanging digital information between BIM tools and GIS, because we are now not only looking into what BIM can be done in the construction project, we need to integrate GIS data so we can plan effectively or we can design effectively and efficiently. So BIM may reuse GIS data captured from initial site surveys for design and construction purposes. So once a built asset is complete, after construction completed, kalau kita ada BIM project pun memang kita we have to prepare a as-built model. So with GIS we can also gather the as-built laser survey. We can laser scan the whole building and attach it with the included BIM models. That is accurately geolocate the asset and provide information such as geometrical dimension, materials, project facing, cost, and consumption number of occupants. So all of this can be produce useful GIS data from the BIM model yang kita dapat tu. So this is how we integrate GIS with BIM. So BIM framework emphasizes the coordination logic that we could have on our future cities. So kat sekarang ni kita dah kena sediakan semua bangunan-bangunan ataupun kebanyakan BIM projects memang kita kena sediakan kita kena sediakan dia punya as-built model ataupun model on the building. So with GIS data we can overlay it lah. We can overlay it dan kita boleh essentially create digital twin on the model on yang ada dekat model tu is essentially a twin of the physical one. So there's so many things we can do when you bring data in one centralized system. So kalau with BIM kita ada CDE, Common Data Environment. With GIS dia ada central tempat yang disimpan all data. So bila kita gabungkan all of these things, we can provide or get a more detailed punya information lah on the project. So this is the BIM and GIS workflow untuk smart cities. So kita boleh nampak lah, in BIM we can use GIS data for preliminary design and planning sampailah ke documentation. And GIS BIM data tu pun kita boleh masukkan in services. So after all the documentation finish, kita boleh masukkan lah. Kita boleh masukkan, kita boleh update pada GIS punya database. So this is the BIM and GIS application. You visualize and locate what's underground and surrounding, so mistake can be avoided. Because as we know, with BIM data, kita just dapat surface level. Kita tak tengok pun what's underground. So bila kita harapkan semua dekat land surveyor lah masa tu, land surveyor akan check, okay, bawah ni ada tanah ke tak apa semua. Tapi kita tak gunakan, in construction kita tak selalu gunakan land surveyor to this whole potential. Kita just gunakan untuk locate locate tanah tu dekat mana, mana batu sepadan dan sebagainya lah. But with the integration of GIS into the workflow, kita boleh nampak, kita boleh tahu, okay, the land surveyor boleh mapkan all the underground punya system. So kita boleh avoid lah in our planning. So next, construction management can track delivered materials and prefab elements on site, and we can also improve safety in construction. Okay, this is the benefit of GIS in construction. So GIS in construction can assist project managers in analyzing project and ensuring that desired standards are reached. So it's a tool for evaluating the project's performance and execution to quantify progress based on cost and the amount of work done. So management can use GIS software to track not just the cost of a project and the work completed, but also compare and evaluate multiple company initiatives and ensure that company's business objective is not jeopardized. So kita boleh dapatkan from previous project and compare it with the current project, so we can make an informed decision lah. So next, GIS application saves a lot of resources because the software controls the building process, checks, monitor, and tries to finish the project on time or ahead of schedule. So with this, we can save time and money. It can also assist in resolution of complex design and construction issues. So a BIM manager ataupun construction manager can rely on 3D technologies or 3D models to know the exact status of the project, because it offers considerable benefits in coordinating development with constructible design and sequence. And with if we apply GIS data into our design, so we don't really have that problem lah. Kita tak ada problem on constructability of design, on macam mana you guys tahu tak satu bangunan dekat London tu yang all mirror tu, yang dia boleh cairkan kereta lah apalah. So with GIS essentially kita boleh nampak lah the surrounding tu macam mana. If we build a building with that kind of design, what will be the impact on the surrounding? So with GIS kita boleh avoid that issue lah. So the limitation of GIS is, first, it is costly because we have to interact with different softwares. Sama macam kita gunakan BIM kan, kita ada Glodden, kita ada CosX. Sama juga dengan GIS, dia ada banyak software yang digunakan dan tak semua software yang digunakan boleh interoperate with other softwares. So aside from technology and software, we need to also have properly qualified human employees that can use GIS and can integrate GIS into the construction workflow. Because as we know, GIS punya profession is not really integrated with the construction process. Even kalau you pergi kat JUPAM, Jabatan Ukur dan Pemetaan Malaysia, they don't really know how GIS can be used ataupun how GIS can be used to help in construction. They don't know where they fit it. Dia tak tahu dia duduk dekat, dia boleh masuk dekat the earlier phase, the initial phase, ataupun dia just masuk kat semua phase. So they also don't know where do they fit in the BIM workflow. Second, integration with traditional maps is difficult. So a GIS system is made up of incredibly sophisticated map structures and information. Saya kata tadi kita ada vector data and raster data. Dan with this kind of data dan all of the attributes, kita boleh asingkan lah what we want. But if we want to integrate with the traditional map, it will be difficult because uh, traditional map pun kita tak tahu dia buat bila dan kita tak tahu dia update pun bila. So with GIS system can only work with and understand data that is collected using the software from the beginning. Kalau kita nak tiba-tiba masukkan kita nak selitkan ni lah traditional map tu susah sebab dia basically dia digunakan daripada awal sampai akhir. So kita tak boleh nak directly integrate with the traditional punya maps. Sama lah kalau kita buat BIM project kan. Susah kalau it's better that we use BIM during the initial phase design, planning apa semua tu daripada bila semua dah settle, bila nak construct baru guna BIM. So it's defeat the purpose. Next, extensive damage in the event of an internal failure. Because the GIS system contains many sophisticated components internally, any fault or internal outage will result in extensive damage and will take hours or days to rectify and return to operational status. Fourth, extensive data storage. So a GIS system can store massive volumes of data at any given moment. So due to the intricacy of the data and the risk of generalization, this could cause issues when it comes to analysis. It also causes difficulty in terms of interpretation because the data yang kita simpan dia memang banyak kalau untuk GIS punya use case. Kalau software BIM paling besar pun saya pernah nampak memang 2 gig je. Tapi for GIS punya data dia lebih kepada 100 plus gigs untuk satu kawasan yang kecil. Sebab kita the extensive amount of data that dia capture daripada photogrammetry dia, daripada dia punya point cloud data dia, daripada dia punya apa yang kita insertkan dalam attributes dia tu, macam parameters lah kalau dalam BIM. So the data will be huge and the process of processing, the time needed for processing is also long lah. That is where we see the time consuming part. The process of gathering, storing and evaluating data using GIS system is lengthy and tedious and hence time consuming. And due to the magnitude of data available, it may take a long time to obtain complete information about a certain set of data. So for conclusion, GIS can be used by construction parties to organize and share data, as well as to create easily understood reports and visualization that can be analyzed and communicated to others. As a result, GIS are becoming more important in construction, businesses assisting with all elements of the infrastructure and building life cycle. Like I said before, we can use GIS punya inputs in many of the things. Bukannya kita gunakan on the earlier part je, macam site survey ke apa. Sekarang ni memang kita gunakan ukur tanah ataupun GIS lebih pada untuk initial part je, untuk kita dapatkan the surrounding apa semua. But we can also use GIS punya data to accommodate all of the phases in the construction project. Okay, ada soalan ke? Do GIS has the same point cloud as 3D? Yes, because it's essentially the same thing. The TLS is a method of gathering data, but GIS is like the center, tempat kita kumpulkan data. Sama macam BIM, kita gunakan Revit untuk kita create a model, atau create a data, but we use the term BIM or to the term BIM is essentially the large part lah. So GIS is the BIM, is kind of like the BIM lah. Kita simpan semua dekat a centralized place. Kalau BIM kita simpan kat CDE, Common Data Environment. But kalau GIS kita simpan dekat ArcGIS ke apalah. Soalan lain? Okay, tak ada. So that is all for today's topic. Okay, jap. Okay, kalau tak ada soalan, itu sajalah. Semua boleh disurai. Terima kasih.